Alright, it's time. Let's go. Excuse me. Was it? How far did we get? Alright. Object being returned must... Okay, yeah. And we were saying this because it's probably fine because data members exist for an object. So if we call a function on the object, well, the object existed when we called the function its member function. So all of its data members should exist. Therefore, we should be able to return references to it. I'm not sure why we would want to, but sure, we could get a reference to a data member. And if as long as the object exists, we could pass that as a reference to something else. I wouldn't want to pass it in its own data member, but here we go. So if we have, let's see. Okay, I've already read part of this. Could be expensive. We could have an employee that has some functions, but it has a data member called mname. And we can set it, and we can also return it. But in this case, if we're returning it, it's private by default, so we need an access function to get it. But in this case, it would make a copy of a standard string. Yeah, makes sense. Yeah, it exists, yep. It's a nice little mystical song here. A good loop time too. So now in this case we're returning by reference, and we can use that reference. Gotcha. Because if we get it and we return the value as is, then we're copying. So we could have a player, class player, and we could have a standard string name, or well, mname, and then we could have public, and here we could just say private to make it explicit. Okay, we could say we return a const standard string reference called getName and return mname. Player Ethan. Oh, and I actually can't even, it's private, so I can't actually even set it. So in this case, we may as well have a set name as well. And at this point, does it make sense to just do this? And that looks interesting. So there's getName, but then there's void setName. And in this case, let's just say we take a standard string, well, a const standard string reference name. Mname is name. But now we can do Ethan.setName to be Ethan, right? So we're converting it, and if this was not const, and this is just a reference, then we have a reference to an R value, because this is, well, actually, I guess a C style string is an R value, but the point is that it's const, so we can't drop the const. So we make it const. And this would be okay because we can convert it to a standard string, but we can't convert it to a reference because we can't have a modifiable reference to a non-modifiable value. Okay. And now we can say ethan.getName. Well, and actually in this case, we're going to do include iostream because we need standard character output. Ethan.get Ethan's name is ethan.getName. Boom. Okay. So we can get references like that. This is a temporary reference to this member, data member. Okay. So we can access it cheaply. We get name, it's returned by reference, not by value. And it exists because there's an object called Joe that exists. Therefore, we can get a reference to Joe's data member because Joe exists. Therefore, its data members exist. And if we do the same thing here, but we don't default initialize it and we don't set it. Oh. This is probably undefined behavior here. We're just not getting issues because I'm surprised it's okay. Guess it's because we're getting a reference to that object and then we can use it. Like see, so here it's not cool. Oh wait. I'm not trying to modify it, I'm just trying to see what it is. Oh, okay, so we can get references to, we can do non-modifiable, we can use non-modifiable references to L values that haven't been initialized, which should be undefined, but it's not caught by the compiler. Sweet. I think it was because there was a section that talked about not putting an initializer. Classes are safer than regular objects because the members are default initialized with 0 or like blank. And maybe they're not undefined. They aren't undefined. just like regular references. Yeah, so there aren't. Oh, gotcha. This was before. So if we wanted a string view, if we had a standard string, we may as well return a reference to it. And then if we need a standard string view, we can say that there's a standard string view and it's assigned that value, or it's assigned to point at that value, instead of returning it as a standard string view. Yeah. Because name is standard string, we wouldn't want to return a standard string view unless we want that conversion every time, which we might not. Yeah, I don't want auto. I don't like it. Yeah, that way we're using an auto reference and it stays constant. It becomes a reference. That way it stays a const reference to a standard string. Because if we're returning the name and we're saying auto, we have to say, okay, well, what type actually is mname? Oh, it's a standard string. Oh, we're returning a reference to a standard string. Yeah, I agree. Just muddles the clarity if we use type deduction. R value implicit objects. Oh, meaning a temporary one, and then returning a reference to that. Yeah, because if we create an L value or an R value object Joe, but we don't name him Joe, if it's not named, and then we return a reference to the data member after the object is destroyed, we return by reference, then the data member and object are both destroyed, and then we use that reference, what happens? Within the expression that it's used. Makes sense. Makes sense. It's basically the end of the line. It's the final resolved thing. Once the full thing is resolved, then it's done. It's gone. Okay, we're outputting create employee. Gotcha, yeah, because we're creating an employee, initializing it with a C-style string that is converted to a standard string view as its one data member, and then we're calling .getName to get the employee's name. And create employee can take the C-style string because it calls setName to use it, because we can't actually, it's private, so we can't access it out here. And the class doesn't have a set name. Well, hold on. The class does have a set name, so we could have just called it there, but it's fine. This time though, we're creating an employee and we're getting the name, but then we're getting a reference to that name. But after the object is destroyed at the end of this line, then we can't use that reference later on. So end of the full expression, the full line, standard character output, we're outputting a reference to we're outputting a dangling reference, a reference to a data member of an object that doesn't exist anymore. We create a standard string and store the name, so we're actually making a copy of it by reference, or we're using the reference and we're making a copy of the value, so we're copying it. And then I'm just using that value that exists. Makes sense? Yeah, because it's unique and persistent. Yep. It's just a temporary object, a temporary class object in this case, which is an R value. Or references to the object itself are dangling, yep. It's used immediately, so it's okay. And after the full expression, they're destroyed, yep. But in case 2, we're returning it, and then we're using that reference later. We're setting a reference to it. Yep, we're getting a reference. And that reference is used to initialize a reference, a reference variable. Problem though is the values have been destroyed and now ref is dangling. Makes sense. It's basically after the full line. So we evaluate it, and then we also evaluate the initialization, which returns the left-hand operand. So if we want to save it, we may as well copy, right? Yeah, because if we use a reference variable, we're referring to something that doesn't exist anymore. We have to copy the value. Yep. Still just regular reference shit. Yeah, just don't do it for R value implicit objects. Just in case it's temporary. Don't save it unless we're sure that what? It's not. Yeah, that makes sense. Unless we're sure that it's an L value and not an R value that'll be destroyed. Makes sense? You may as well just do a little expensive thing just in case. If it ends up being an R value, you get undefined behavior. I'd rather expensively make sure that we've copied it into an L value to be used later and to become persistent. Do not return non-const references to private data members. And that's because we're effectively giving access to private data members elsewhere. They aren't const, so they're changeable, but they shouldn't be changeable outside. Yeah, I mean, an example of this would be Just explicitly say it. Oh wait, hold. Or let's just say by default it's false. Oh, what were the two issues it had there? Oh, it's a reference to the function, I think. Yeah, that makes sense. It's a reference to a bool reference returning function. Nope. Problem here. We don't have any way inside firearm to set is reloaded. I don't have a setter. I only have a getter. The problem is the getter is returning a non-const reference. If we do this now, we're cool. The issue is right here, where we are assigning it. We're converting a const reference to a non-const reference, which we can't do because then it violates the constness. Yep, can't convert a const reference to a non-const reference. Excuse me. Yep, exactly. So if we have value and we shouldn't change value, but we return a reference to it, we can change the reference, which will change value. True, we could have actually just done the syntax. Well, the syntax is fine. It's just this isn't how you would want to do it, so I wasn't thinking of it. I would think that we would have to save it because this should only be returning a const reference, not something we can actually change, but it's returning a excuse me, a non-const reference, which means we can actually take the return value and change it because it's a reference. That's cool. If we had a const member function, we have to return things by const reference because otherwise it can change. Otherwise the member function or the member data members would be changeable through that reference. Curious real quick about one thing. Oh god, not these. Yeah. Makes sense. Cool. Interesting. The return can't convert from constant. Hold. Qualifiers dropped in binding reference. So when you put const in the function like this, const in a member function, it assumes that anything you return data member wise is const. So this would be okay if we did this. Okay. Makes sense. Encapsulation Y. I mean, I was trying to figure this out yesterday. I mean, if we have I mean, if you were within a team and somehow you literally didn't want someone to be able to access something from somewhere, then maybe that. Well, no. What's the real purpose of that? If I'm in one file, I was thinking about name conflicts, but if I'm accessing gun dot is empty or gun dot is empty, or well, an object of the gun class, so we'll say AK-47 dot is empty, or dot get bullets remaining to get the value instead of just doing dot bullets remaining. What is the point? It's not a name confliction because in the same scope, if we had something called bullets remaining, well, there's no conflict between those two identifiers because they're in basically separate scopes. One is within a class definition, the other is just within the current scope. Is it just a way to put the programmer on a leash, just to make it so that you have to do .get something and .set something instead of just being able to change it? I'm not sure. I'm really not sure right now. I'm probably missing something important. What effects would you might? Okay. The benefits of encapsulation. And right there, I was watching XQC play Mage Arena, I think it's called, and it's this open world. It's like this big map with a bunch of different biomes that seemingly are maybe randomish, but not really. There's a bunch of different versions of the map, and there are flags that you can capture. I'm not really sure why, but you have your base flag and the enemy flag, and you try and capture the flag. If you capture their flag and then kill them all, you win. So, and if you lose your flag, you can't respawn. So if you capture the flag or you get yours captured, you can't respawn. So once you all get killed, then you lose. That's how you win and play the game. There are items you can collect. There are spells you can collect. You have a spell book with like 4 spells in it. I think Fireball, Magic Missile, Freeze, and Worm and Hole, Wormhole. And you have to speak them out loud. So you have to say Fireball or Freeze or Worm, and then later on Hole to some of the other part to connect the two. To jump from one spot to another, like point A to point B, B to point A. You could say hole and then worm, worm and then hole, etc. So it's really cool, and you have to say it, and there's VoIP, so you can hear other people yelling it, and it's hilarious. But I'm trying to think about how that would play out in a first-person game. Like I could see, like I don't know. I want to enhance single-player experiences in video games where you have complex lock-picking mechanisms, or maybe puzzles or hacking things. So if you're in a game like a VR first-person game in the same setting as Arc Raiders, where you're going and you might have to pry some shit open and pull tools off your back to open things up, but maybe you actually have to hack some things. You can hop on top of a drone, or maybe you kill a drone and then the security system is still up afterwards, or maybe the only way you can, like, maybe they get destroyed when you fully destroy them, so what you have to do is damage them enough to where you can then hack into them to pop something loose or get access to data that you can sell for more, something like that. And you have to do puzzles and things. I'm wondering also about spells and magic and whatnot, and having to actually speak the things out loud, which seems cool. I mean, sure, there's drawing spells in real life, but I mean, in Dungeons and Dragons and magic fantasy in general, there's a lot of, it seems like there's a lot of speaking where you're saying stuff and weaving words together to make combinations and unique spells and whatnot. It feels like it would be more immersive. That would be cool. I mean, I'm imagining walking into a lich's lair and I hear this ancient, decrepit voice, like one of my coworkers, just whispering words, and I know it's about to go down because I recognize that those are magical words, or words that I've never heard before that are probably some ancient language or something like that, or in some sort of magical script. I don't know. It seems like it would be cool. I'm gonna append my response real quick. I hate that I can't edit comments in the little short preview thing. Oops. Okay. Yeah, member variables are normally private, sure. Why? Yeah, I haven't seen it so far. And the point here is what? The things that happen inside a remote control that send the actual signal that we want is more complex than simply change the channel. So I press a button and a bunch of things happen. If I don't have if I have a class that does something, I want an interface to do that specific thing. I don't want to have to go in and deal with what's actually going on. Maybe meaning that I'm struggling to, or I don't yet understand why you would want that for. And maybe it's because the process by which value is assigned to a data member might not be as straightforward as assigning the value you want to it. So maybe you say, like, I'm thinking like a not a Kamiga Kill, Gundam, like a Gundam game where you have suits, right? Big metal suits, and you want to repair the Gundam or like max its energy out by giving it an energy crystal. Well, the code might just be maybe there's some calculations that happen. So like depending on what the crystal is, the health will get set a specific way. So instead of the programmer having to say, hey, suit dot energy level equals something, and maybe you don't know that right away, you just know that you have a small energy crystal. You then have to figure out what value a small energy crystal actually gives, and then put that in there. But instead, you could just say set suit dot set energy, and then in parentheses you just pass it the energy crystal, and then in the setter you say you have a switch case. Let's say that your energy crystals are an enum, and you pass in the enum value and you switch on it and you say, hey, if it's small or medium or large, set the energy to 25, 50, or 25, 60, or 100. So you just called set energy and passed in a crystal. What really happened was a switch case deeper down that took the crystal, found out what value matched it. Okay, so it's like having it's like if you're a TV programmer, I guess, or you're like some sort of technician who works on a TV because the TV is important to your work and you use the TV a lot to do things. Well, you want a tool to interface with the TV. You don't, every single time you want to do it, say, hey, change channel, or remote dot change channel in parentheses 100 amperes 25 volts in this fucking whatever else. You just say change channel channel B, done, that's it. Or channel 200, that's it. There might be more going on. So in the case where the variables are 1-to-1, we could just set it to be whatever, like a player, and we're updating the health to be 100 or this or that or the other thing. Maybe there are other properties in the character where it's not so easy. So maybe we call character.apply damage. Instead of saying character.health is now 75, or is now itself minus 25, so now it goes from 100 to 100 minus 25 to 75. Instead, maybe it's character.apply damage, and we apply 25, and then apply damage checks how much damage should actually be applied, so that you, the programmer, don't have to do the calculation of, oh, it's going to be here now, or you have to make some complex logic. It's already handled in the class, in the setter. So we say, hey, we try to deal 38 damage, or we try to deal 50 damage, but then in the set damage, it actually calculates that only 38 damage gets dealt. Why? Because it takes the damage dealt minus the character's resistance, and the resistance is 12, so it reduces the damage done by 12. So instead of 50, minus 12, it's 38. So then the damage dealt is 38, the health goes from 100 to instead 62, instead of 50. So it's 12 higher than you would have expected, but you didn't have to worry about that. All you did was call .apply damage. So in all your little other things that interface with that class and use that class, you just have to do .this, .that. That's it. They do damage, you apply the damage. They do this, you do this. You don't have to go in and say, apply the damage, set the health to be the damage dealt minus this, that. No. That's already handled in the setting and getting. So the point is, when the process of setting, I guess setting is probably more important, but maybe getting too. The process of reading the data members isn't as simple as getting the value of the data members, I think. How these devices actually operate is hidden away. When you press the button, you don't need to know how it's communicating. When you press the pedal, you don't need to know the combustion engine. When you take a picture, you don't need to know that the sensors are gathering light and turning it into a pixelated image. It's useful because objects, we can use objects without having to understand. We just understand how to interact with them. Makes sense. I mean, you don't have to know what's going on inside your arm and how you're diminishing and using ATP and whatnot when you're choking somebody out. You just know, oh, I have to do it this way for this guy and this way for this guy because of their behaviors. That's it, done. It's the same reason that you have Blueprint visual scripting languages in Unreal Engine and in Unity. That way you just have to learn how to interface with something and what to do. You don't have to necessarily know. You don't have to know what's going on deeper necessarily, but maybe you do, because if the useful part here is creating those interfaces, those tools, and not being limited in them. That way I can create my own custom animation software, my own custom damage dealing software and response software, where counter software, where you attack an enemy and I have something that automatically makes them counter. I don't have to attack them and then manually say counter, it just happens. Interface and implementation. The implementation being the specific shit that's actually going on underneath the reality under the hood, whereas the interface is how we interact with it. The apply damage, not the actual set damage to be this and that and the other thing. Yeah, I'm very grateful to have played Death Stranding and almost more Expedition 33, because now that I've seen the tools that they've been made in, I'm excited to learn how to use those other things, not just not explicitly programming. Programming will be helpful, I think, so that I don't have any limits to what I can do, and I'll have a deeper understanding of what's going on underneath the abstractions of Blueprint. But like right now, I'm excited to eventually work on a particle system to create like accurate little footstep clouds and attack effects and whatnot, and like a little cut through the air with a sword going through it, something like that. That'd be sick. And blood splatter and whatnot. Oh, that'll be sick. Oh, I'm excited. Make me tear up. All right. Public members of the interface makes sense. Assuming that the private members are the ones that we can't. Well, assuming that the private members. Well, yeah. Assuming that the public members are all member functions that are used to interface to access. To interface and access the private members. A public interface. And maybe we have private functions that they also call to. Okay, that makes sense. Public is all that we need to see when we're looking at a class. So if I'm the programmer and I do player dot whatever, maybe I don't want to see dot health, dot speed, dot this, dot that, dot this, dot that, dot that. Instead, we just have player dot apply status, which applies the speed and changes the mass and changes the gravity and all the shit, and player dot set health or get health. Boom, that's it. When I look at a chair, I don't see all these different values. I just see, oh, what are the behaviors associated with it? Maybe like a couple other things too. Like I can get the properties of it, but I don't inherently see all of them off the rip. Hmm. It makes sense. If that function to apply the energy to the Gundam changes and does it a different way, then the behavior might change. Makes sense. Data hiding. And the reason I make it so that main can't access these specific little properties we don't want to touch, and we only want it to operate on the TV using the remote, is so that when I'm using the thing in main, I don't have to deal with all the other shit. It's like I'm the customer and the salesman. I sell the car that has a nice user interface so that when I use the fucking car, I can use that interface and not have to worry about all the other shit that I know but don't need to know. Make sure the data members are private and the member functions are public. Boom. Okay. Mm. Encapsulation being the act of packaging the functions and data we want to manipulate and get together to create an interface through which we can access the information that we actually need. Okay. Okay. Having been programming for a few months now, yeah, honestly, this is nice. Like just being able to just memorize what's in a string, or like what functions we get from string view with CPV reference is nice. Don't have to know all the shit that's going on underneath. We just memorize the parameters and boom, done. It's getting too hot. And if we maintain invariance, then we don't have to worry about fucking things up when we're initializing or changing values of classes. Instead, we can just use the public interfaces to change the values without fucking up the invariance. And then we could call set set fraction, and it takes two guys, and then we can have a while loop so that we can't give it 0 as a denominator. Oh, gotcha. And now that we have the name and first initial, we can say that whenever we set the name, it sets the first initial. How to get the first initial? I'm not sure, but we'll see. Yeah, because we have employee E, it starts with John and J. Then we change it to Mark. Well, first initial isn't changed. I'm guessing there's going to be a member function here to actually set the first initial. And up front, there it is, front. Let's check this out. Returns reference to the first character in the string, which we only need for one time, so. Okay. Gotcha. So for example, we could have what are some things we would want? We could say strength and attack power. So we could say int strength, int attack power, or like int damage, sure. And then we could say public we could get via reference, or we could just get, I mean, it's not that bad. We'll just return int get strength. Okay, but then we could say int get damage, return damage. But then we could have void set strength, and it takes an int new strength. Oh, and this should be... Okay, but then damage is now, let's say this is 50, this is 100. Damage is 2 times M strength. So now we could say so we could create player Ethan. Ethan dot. We could do these things and that's it. So we could say set name to be Ethan, and then we could say Ethan dot, or what we could say. And this should be okay. Everything that needs to be const is, except the manipulating guys. Cool. How about we say getters, 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 and then we could have setters. Okay. Boom. So Ethan's damage is 100. We've set the strength to now be 100, and now Ethan's damage is 200. So we can't directly manipulate the damage, but we can equip an item, and the item will call set strength, and boom. You can see how this would play out in an RPG. You pick up a new sword, and the sword has some sort of attribute on it that raises your strength by 2, or maybe it has something that raises the damage, and you equip it. And it checks if that object has been equipped before, and then it does something called update damage, and maybe that's, I don't know. Yeah, something like that. It would be cool if we could have a special access for that. Because I don't want everything to be able to set the damage, but maybe we want a sword to actually do it. Or maybe it stores the object, actually. The class has the object, and the damage is plus whatever the object's damage is. So we don't have to do it in the sword. We just, the character picks up the sword, and the character's damage adjusts accordingly. It's not that the sword is adjusting the character's damage, it's that the damage the character's damage is being adjusted because of the sword that it is holding and including. Okay. Excuse me. Wow, it feels like I have an entire August and September. Damn, I still have 2 entire months of learning. This is of cool shit. Let's go! Alright, I'm super excited. Holy shit. Okay. Oh yeah, let's copy this real fast. What? I mean, it's cheap. So, well, in this case, it's a string, so we'll just do const character. Do we want to convert to a standard? I think we do. We like receiving by string view. I mean, do we care about const? I guess not. And this should be really... Yeah, I guess this can't even be const expression because we're in a class. Oh, we actually can? I mean, why not, right? This won't be happy here, though. Yeah, because it doesn't evaluate to a const. Oh, it's actually cool with it? Oh, because... maybe it is initialized off the rip? I don't know. Okay. We'll try that. So we'll set the name, and this will be name. And then we're going to say mName is now name. M first character is mName.front. Okay, and we can create an employee called Ethan. Alright, and we could say Ethan.set name. Okay. Well, Okay, but maybe we check this. Or instead of this being Ethan, we're gonna do employee. Sure, we'll just do that. And so we have Ethan, first character Z, but then we set Jack in first character J. So we have this invariant must always be names first character. Public interface. Well, that preserves the invariant truth. That keeps invariant, that ensures ensures invariant m first character is true. Cool. And this could probably, we could still make this be const expression, right? It's not a const member function because we're manipulating things, but it could be const expression because maybe we can call this at compile time if we somehow know where all this shit is in memory, which I feel like is doubtful, but I don't know. Anything else we could do? Don't want the data members to be const. Turning a const reference or just a const character. Because we don't want it to be, well, I mean, it doesn't really matter if it's a const char, but. And if this guy wasn't const, can't drop it, buddy. Why? Because you return him. You return him as const, brother. You can't then not return him as const. Your function says you're not returning anything that is able to manipulate the parameters, but now you are, buddy. All right, so here's the issue. I mean, sure, we could include an assert in the print too. But then every time we call it, we're making sure that it's dot front. I don't know about that. I don't like that. Well, that isn't necessarily, well, the reason this happens is because we're setting the name. We're not calling something that preserves the invariant that does a few things. The point here is that, sure, if we don't have any invariants, maybe we just want to set the name. Cool. But maybe we want to check some things. Like, let's say the name, maybe a certain name is disallowed. So maybe you want to set the name as a function and check to see what name is the user trying to send it to. Oh, he's trying to name his character God. Maybe that means that you're born with a crazy strong trait now. Or maybe that means that you actually can't set that name. Depends. These are some cool ass chapters. I like this. This is C++ is really fun. I'm proud of myself for sticking through some of the boring stuff. But honestly, it's been cool for a while now. Even like asserts, static assert, these are cool. Especially for games where we have shit that we want to be true that we might not expect to become untrue, but we still check to make sure that it is true. Like, I don't know, that the player speed never exceeds a certain threshold or something like that, if wanted. Like, if you're in a ship and the spaceship, is only capable of a certain amount of speed under any circumstance, we don't want it to be glitching and bugged out, right? Excuse me. Yeah, because we're not getting the first character. It's the first character is incorrect. Yeah, yep, exactly. You become responsible for that. Unless we don't have an invariant, then okay, but yes, we have the name, we have the set name, and we could say the print the information. Okay. Instead of 2 getters and 2 setters. Instead, we have a setter that sets both. I said I had a setter and 2 getters, but instead this is just 1 print instead of 2 getters. Yep. We have employee E, set name to be John, print John J, set name Mark, print Mark M. Yeah, it's true. To do better error detection and handling. Yeah, because we actually get to check it. We don't have to set something and then nothing checks, nothing changes, nothing. Maybe the character is alive and the character is moving around at speed 100 and we set the speed manually to be 200, but we didn't actually mean for it to go all the way up to 200. Maybe we meant for it to be 20. We meant for it to be slower because 100 maybe is the maximum. You're sprinting at 100 and then we want maybe the character crouched and we want to set their speed to now 20. You're moving to a fifth of your maximum speed. Well, if you're moving at 200, now you're even faster, but we only see that when the character's moving. If the character's standing still and we set the speed, when the character starts moving, boom, then we see that it's fucked up. But maybe we did a bunch of other things after setting the speed, and now we don't know why the character's moving so fast. Instead, we do set speed, and we make sure that, hey, boom, 20. Instead of having to go and find out all the places, it's kind of like a global variable, where we don't want everything to be able to set the speed however it wants. We want it to set it through the interface. I don't want my grandma to be able to look in the remote and then do all this crazy stuff to it, maybe, and fuck it up. Or like, I don't know, you have like a kleptomaniac sister or something like that, and you go in the store, you don't want her to be able to pick up all the stuff. You want her to have to go up to the damn gate and say, hey, I want this thing. They give it to her, and then boom, you can tell. It's like Skylar's sister in Breaking Bad. You want her to operate through the store's interface. You don't want her to just have access to whatever, because then you don't know if she was even the culprit. She was, but you would have only known that if she had operated through the interface and she tried to steal the shoe. Yeah, or so instead of having an invariant like that, we could replace it, and then instead, if you ever want the first initial, you just get the first initial. Instead of having to set it every time and maybe never use it, instead, every time you use it, you call it. But maybe the calling is expensive, I'm not sure. Here's John, and then we're probably just returning front. Yeah, exactly. We're returning front of the name. Named up front. Really M name front, but whatever. We're just returning there. And we have set. Hold. If we call set name, there's an invariant here, so something that must be true. Is it that it needs a name in the first place? So if we create it and it defaults to John, but then we call it with set name with nothing, no argument? Well, yeah, but wouldn't it error if it didn't take an argument? And if we set it to like a funky character, wouldn't the character still match and be okay? Not sure. Name shouldn't be an empty string. Well, yeah, but maybe, I don't know. Well, if it's set to it, nothing bad will happen immediately. But if it's called, then we get front of it. Oh, so it actually is an issue. I figured that an empty string would be some sort of like null terminator character. Like there's something technically between the quote quote. But okay, there's not. So if we're doing that, we're getting the front of nothing, which is undefined, which means what? What does front pull from? Maybe it pulls from something in front of that, so it's pulling from earlier memory? I'm not sure. Okay, prevent a name from being empty. And so what? Just make it so that in the set that name can't be empty? Yeah, exactly. Excuse me. The hokey pokey. What? We could have a while loop and only do it once the shit is correct. You could ignore it. You could assert out or throw an exception. Yeah, I don't know about that. Oh, I guess the point is that if you're calling it, it's not input. We're not doing standard character input. We're just passing it the value. So we could, also it could just do nothing. It could return nothing at all. But if it needs, well, yeah, it's not returning a value. It's just void set. So it could just return. Checked it and handle it. Yep, cool. Change implementation details without breaking existing programs. Yeah, because everything already, instead of having, so if I change the implementation, so instead of the name being called this, now it's called that, or instead of it even having a name, maybe it has something else that is converted into a name. Well, if everyone is using .getName and setName, and we leave things as getName and setName, then everything works as fine as long as we make the implementation work out. But if we change the implementation and the actual logic in the interfacing logic is using the implementation explicitly, then it's going to be fucked because the implementation got changed. It's like, change the shit in my house or change the front door. Leave the front door, change the shit in the house. Boom. You can still get in the house. You just can't fucking come through the window. Yeah, if we were doing .value1, .value2, and we changed those names, then we're going to get some compiler errors. But instead, if we do something .setValue1 or setValue2 or set values or something, and getValue1, getValue2, getValue3, then nobody gives a fuck what the values are actually called. We do when we're making the implementation, but that's it. And here it is. You changed it to be, oh, so now there's a value of 3 that has 3 indices, 0, 1, and 2, I guess, right? We created something, we do something to value 1. Bro, value 1 doesn't exist, motherfucker. Yeah, it doesn't exist. But now we could do set value 1 and get value 1. Oh, well, we don't give a fuck about values 2 and 3. Okay. Setting value 1. Or hold on. Yep. And getting value 1. Returning is int because it's cheap. We're creating a something. We're calling set value 1 now with 5. And then we're printing get value 1. Cool. And then we can still do set value 1 and 5 and get value 1. But instead, now we have value 3 and set value 1 is it sets the 0th index and it gets the 0th index. So the setting and getting still works. It's just that the identifier changed and we don't have to worry about that. So if we were accessing m value 2 and m value 1 and 3, we'd be fucked in this case. I mean, technically the interface itself, the logic in here changed, but it's still called the same way, so dependent logic didn't change. Yeah, true. Gnomes? Why gnomes? Yeah, it was a lot of shitty. Okay. Easier to debug. Yeah, because, I mean, it's easier to search just like for global variables, as I said earlier. Yes, exactly. Yep. Prefer, no, what? Don't make it a member if it can't, if it doesn't have to be. Hmm. Meaning that we have a non-member function that accepts value somewhere else. We don't have to worry about passing that other value to the class itself, maybe? At least if it stores it. Really? They don't even support non-member functions. Damn. I think for my self-test later, we'll do 45 minutes and we're just gonna do the most recent 2 chapters and then random for everything else. Member function when it needs access to the data that shouldn't be exposed. Okay. Or, I mean, when we're doing it when a class needs the behavior, seems like. When a character needs to attack something else, we pass it what to attack and then boom. But maybe we don't actually need to do that. We pass in the object of the attacker and the attackee, and it's outside somewhere else. So maybe it depends. But maybe if the character's healing, then we do it. So I could see this different ways. A challenging case is a non-member requires the addition of access functions to facilitate. Hold. Meaning that a non-member function needs an access function to do something compared to just making it a member function to where it can see it as is. You gotta figure out. If we add it, create member functions. Yeah, exactly. Okay. Wasn't ready. Cool. All right, that's it. Self-test. Well, not even self-test later. We're going to do 45 more minutes and then self-test. And then, oh, and actually today's weekend. So I think I'll just keep on going as is. Another hour and a half of straight learning, and then another hour and a half of straight learning, and then 45 minutes, and then of straight learning again, and then 45 minutes self-test, I think.